Okay.
So we've got a perms and coms question over here that we might need to do a little bit of thinking about. So let's read the question very carefully and consider what they might mean. You have the number of ways of arranging n students in a row such that no two boys sit together and no two girls sit together is m. So m is some number representing the number of basically arrangements. And another way to express this is that you've got alternate seating between the boys and girls. If one more student is added, then the total number, of course, goes up. So the number of arrangements goes up. And importantly for us, it goes up by 200%. We're going to need to use that information later to get what we want. And the question asks us to explain a few things. One, explain why the difference between the number of boys and the number of girls cannot be more than one. Two, show that n cannot be odd. And three, find the value of n. That's our aim. So part one is probably a little bit easier, and we'll talk about that first. Just think about this scenario. You've got a few seats. And let's say you had more boys than girls. So let's say, and the difference was more than one. So let's say you had 3 girls and 5 boys, hypothetically. So let's say we put the boys first, and the next one can't be a boy, so it has to be a girl, just because we're making sure they don't sit together. You've got a very strict school, right? 1, 2, 3. Okay, so we make the boys separate, and we're separating them with a girl in between. But hey, we only have 3 girls, which means there's no one sitting here, which means that these 2 boys will be sitting together. If you have a difference of more than 1, then whichever one that you have more of, whether it's boys or girls, you can't possibly separate them out with the other group, right? I mean, I could have just 5 boys and 4 girls. That's okay, right? I've got 3 girls separating out 4 boys. 1, 2, 3, 4. There are, if you like, 3 gaps between the 4 boys. And so the 3 girls can accomplish separating out the 4 boys, if you like. You can think of the girls in this case as the dividers of the boys. But if I were to have a 5th boy, no matter where I put him, I'm going to need an extra divider between this boy and any other boy. So it could be here, it could be on here, it doesn't matter, it could be in between, but I'm going to need a new divider, and I don't have that. So the number of gaps is going to at least be 1 less. If you have not enough dividers, then it wouldn't work. And so very simply, because you need enough of them to sort of separate for alternative seating under these conditions, we require n minus 1, I guess, let's say girls, to separate the n boys, or vice versa. And that should be fairly straightforward. Now, the second part, show that n cannot be odd, probably is a little bit confusing as a question, because we've demonstrated that, well, it can be odd, right? I mean, we demonstrated earlier that, well, if I have boy, 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 girl, girl, I have this. This is an odd number. I've got 5 students. It's working. So just looking at this, clearly it's very clear that looking at this only, n can definitely be odd. But we're trying to show that it can't be odd, which really means you really need to consider the next sentence. If 1 more student is added, the number of ways of arranging goes up, so which means it's still possible. So if you have an odd one, I think that's quite clear to us, based on what we said in part 1, that we can't add another boy. If we add another boy, then it's impossible. Because now you're going to have 4 boys, 2 girls, and then well, it won't work for the reasons we outlined. Now, it's very possible for us to add another girl. That's not a problem. You can just add another girl, on the end or over here. And that's not a problem. So we could add a girl. And then you'll get some amount of arrangements. Okay. You would get that. But the thing is, and I think this is where the question's wording could be improved, the question refers to the fact that if one more student is added. So in other words, I think the question is essentially saying that it doesn't matter if the student is a boy or a girl, you should be able to do it. Well, then if we interpret the question in that way, and it's fair that they'd said, student and not boy or girl, and they didn't put any restriction on the type of student that you're adding, then if we were to interpret it that way, then yes, that means the only way you could make sure that you can add any student, boy or girl, to your existing group is that n can't be odd. You must already have an even number, which means the number of boys equals the number of girls, and that is then going to therefore allow you to do that. Okay. So in other words, if you have a situation where you've got something like this or vice versa, but 3 boys and 3 girls, okay, so with this scenario here, you've got 3 boys, 3 girls. If I were to add an extra girl, then I'm going to get 4 girls and 3 boys, which is fine. We don't violate what we said earlier. Or alternatively, I could add a boy, and I'm going to get 4 boys, 3 girls. Again, all of those will both give me new arrangements which are possible. And so basically, if we interpret it this way, we require n to be even to ensure the number of girls equals the number of boys. Therefore, when a new student is added, the difference between the number of girls and the number of boys does not exceed 1. So the last one is probably the most involved, presumably. You now want to find the value of n. So you really just need to find some expression for the number of arrangements. So noting that you've got n students, n is even. So I'm going to, for my purposes, just think of n as even. So I'm going to let n equals 2k. So in other words, I've got k boys and k girls for simplicity. Okay, and therefore the arrangements of n students alternatively equals m, as given in the question, where m is greater than 100, as also given in the question. And so basically, how would we do this? Well, I've got k boys, which is represented in this black. I'm going to basically let them sit. So the arrangement of the boys is going to be k factorial, or which k is n over 2, right? Is n over 2 factorial. And then that means with these k boys seated, I'm now going to have, well, I now need to have basically the girls to go in between them. So given that it's equal numbers, I could have, I'll just say hypothetically, the girls and the girls sit to the left of the boys in this case. So I will have k spots for girls. So if I did it this way, then that means the arrangement for the girls would also be k factorial. So the girls sit in any where they want. And that, of course, guarantees that they're sitting alternatively. But of course, that's also the only way. the other way it could be arranged is, of course, the boys sit to the left of the girls. But that would also be the same thing. So in other words, the total number of arrangements when the numbers are equal is k factorial times k factorial times 2. So in other words, m must equal 2 times k factorial all squared, where k is half of n. So that's when the numbers are equal. Now we need to consider the situation where the numbers are not equal and you have one more extra, let's say girl. So I'm going to now have k plus 1 girls, doesn't really matter, and k boys. Now, because I have one more extra girl, it is guaranteed that the boys have to be the one, like boys have to be separating the girls. So if I let my boys, if I let the boys sit first, so you've got k slots for the boys, and then that's going to be, of course, be k factorial, and the girls are going to be now sitting in between the boys and around the boys in the sense that they're going to be the ones sitting on the edges. So there's going to be k plus 1 seats for the girls. So this is going to have k plus 1 factorial, and there's going to be k factorial. And you no longer times by 2 because you can't get the boys sitting on the edges. It's not possible. Not when they're the small, like whichever one is outnumbering the other, and we don't know which one it is, they have to sit on the edges. So that means the number of arrangements in this case is k factorial times k plus 1 factorial without a times 2. Now, this is with n plus 1 students. And we know with n students, the number of arrangements was 2 times k factorial all squared. Now, if you go back and read the question said that when you added one more student, the arrangement, the number of possibilities, this was equal to m. This was equal to m, which is greater than 100, by the way. But the number of arrangements increases by 200%. Which really means that this over here went up by 2 more times, which means it's 3n. In other words, we now have a relationship. 2 times k factorial all squared times 3, if you like, or if you like, yeah, times 3 equals k factorial plus k plus 1 factorial. And we just solve for k. So you can divide k factorial by both sides. So 6 times k factorial equals k plus 1 factorial. You might want to remember that, well, k plus 1 factorial is 1, is k factorial times 1, k factorial times k plus 1. So we can divide by k factorial again. So that means 6 must equal k plus 1. Okay, so in other words, k is 5. So if k is 5, then that means n is 10. And that's basically going to be your answer. The value of n is 10. It's an even number as expected. And we can just quickly double check. 2 times 10 factorial. I mean, it definitely is going to be a big number. And it's well over 100. So there we go. That's how you do the question.